Objective 2 of Section 1.2, define control in terms of the experimental method and describe the features of a controlled experiment. Well, a controlled experiment is going to test the effect of one variable at a time. That way, if there's any change, it's caused by that variable. It's going to limit possible alternate hypotheses. And the differences in the result should be due to the treatment, whether they were exposed to the independent variable or not. That's what should cause your differences in your groups. Now, when you're setting up your groups, your control group should be similar to your experimental group. The only difference is they do not receive the experimental treatment. They are not exposed to the independent variable, to the experimental variable. Okay? So they're there just to compare to. If I want to know what acid does when you drink it, which I'm never going to want to know that, but if I did, I would give my experimental group vinegar to drink, and I would give my control group water to drink. Well, obviously, the water's not going to affect the control group. So whatever happens to the experimental group is going to be because of the vinegar, because of the acid. Okay, when you set up a control experiment, you need to have a random assignment to the control group or to the experimental group. And you've got both of them, the same thing is happening, except the control group is not being exposed to the experimental variable. That is the only difference. Echinacea tea experiment. Our hypothesis: drinking echinacea tea relieves cold symptoms. We got two groups, a control group and an experimental group. Both groups are as alike as possible, and we're going to randomly assign them into one or the other group. The control group and the experimental group are experiencing early cold symptoms, and they both go to the clinic for treatment. The only difference in the groups is the experimental group is going to drink the echinacea tea 5 to 6 times a day. But the control group is going to drink a placebo tea, just a tea, 5 to 6 times a day, not echinacea tea. So we're going to assign them randomly, and both groups are going to get tea. But our experimental group is exposed to our independent variable. They're going to drink echinacea tea. Our control group is not exposed to the independent variable, so they're just going to drink another kind of tea. So remember, our independent variable is the kind of tea they drink. This says drinking tea, but it's drinking the echinacea tea that it means. The dependent variable, what do we expect to happen resulting from drinking that tea? We'll go back up there and read your hypothesis. Drink the tea, relieves cold symptoms. So we're looking for relief from cold symptoms. We didn't change that one. The only thing we manipulated was the tea. Okay? When we did the experiment, or when they did the experiment, the echinacea tea, the experimental group, felt like they had 33% fewer cold symptoms than the control group that only drank the other kind of tea. So we've tested that hypothesis, and we could have proven it false. But we have proven it true. Now, does that mean we're finished? No. Do you know why? Think about it for a second. Because there could be an alternate hypothesis out there. there could be an alternate hypothesis out there that's not been tested. Don't forget that.